Everyone, welcome back. I'm David Chung, and I'm the dean of instruction, the dean for today. So if you guys can just put your homework in the homework channel, and if there's any questions, I think Elliot will answer them. And then for as of like for today's agenda, I think you guys are just going over the pandas thing on W3 schools. So if you guys have any questions, just ask in the Q&A questions and answer channel. And I'll be handing it over to Elliot to go over the homework problems.
I'm gonna be going over the homework. So the first question, I'm gonna give you guys some time to open that up. Good. The first question says which of the above statements are true out of the 4 print statements. It's gonna be the last question, 1, 2, 3, and 4. Third one, developing a sports application program should allow players to enter their name and score. Program will print player name and his average score. Output must meet the following requirements. And the username must be aligned. If the username is fewer than 20 characters, additional space must be added to the right. The average score must be 3 places to the left of decimal point and 1 place to the right of decimal point. Just like this. And the answer is going to be the first one. Question 4, consider the following code. To print 0 to 6, which changes we have to perform in the above code? It's going to be the first and second answer. Line 1 should be replaced with while index is less than 10, and line 2 should be replaced with numbers index equals 6. Moving on, question 5, you are writing a Python program to validate employee numbers. Employee number must have the format and consist of only numbers and dashes. The program must be print true if the format is correct, otherwise print false, and it's going to be no changes are required for this code and you can fulfill requirement. Question 6, you're coding a math utility using Python, which of the following root function should be used? It's going to be the first one. Next one, question 7. We are developing an online shopping application. Consider the code. To get 5 as discount percentage, which the following input should be provided and user. And it's going to be Thursday. Question 8, we are developing a gold loan application for XYZ company, which the following user input interest rate will be 12, and it's going to be same answer 50,001. Moving on, we are developing an application for leave approval in the XYZ company, in which of the following cases needs director approval will be printed to the console. It's going to be day 4 and cause official. Moving on, consider the following code. Which grade will be printed? And it's going to be C. Question 11, consider the code. In which of the following cases result value will become 9? It's going to be result S. Find not if S else none. It's going to be the second answer. This question, we are developing loan collection agent application. Consider the code, which will be the value of the commission is going to be 350. Next, you are developing online shopping application, which is a result. It's going to be 75. Question 14, consider the code, what is the result? It's going to be 2, second one. Question 15, consider the code, what is the result? This is going to be 19. Question 16, consider the code, what is the result? It's going to be 13 for question 16. Question 17, consider the code, what is the result? This one's going to be the third answer, 31. Number So for number 11, this is going to result, right? Result equals 3 if none else. Here's the explanation. If it equals to 3.0, none is treated as false. Okay. And result equals s dot find not if s else none equals 9. Find method returns the index of first match from left-hand side. And result equals s dot r find not if s else none equals 33. R find method returns the index of first match from right-hand side. And result equals 5 if let s is greater than 4, else 6 is 5. That's our results in find not if s else none. Moving on. I think we were on question 17. What is the result? It's going to be 31. Question 18. Consider the code. What is the result? This one's going to be a third answer. 1. Question 19. Consider the code. What is the result? It's going to be the first answer. Chi, Vin, and Pin. Question 20, consider the following code. X should be replaced with, first one, A, comma, LST, bracket. Consider the following. Which of the following methods calls are valid? It's going to be the first 3 answers. F1, F1 1020, and F1 10. Moving on, question 22. Consider the following code. Which of the following method calls are valid? It's going to be the first one and the last 2. Question 23. Consider the following code. Which of the following code should be inserted to print highest number as 100 and least number as 10? It's going to be the first one. Consider the following code. To print 10 100s to console, which of the following code we have to take at line 1? And it's going to be the second answer. Moving on, consider the code. Which of the following function calls returns 30? It's going to be calculate 10, the second answer. Consider the following code. What is the result? It's going to be the first one, 0, 1, 1, 2, 3, 5, 8. Question 27. You are developing a Python application for online game. Which of the following is valid function to fulfill this requirement? It's going to be the second answer. Moving on, 28. The XYZ company is creating a program that allows customers to log the numbers of miles biked. The program will send messages based on how many miles the customer logs. Consider the following Python code. And the lines, line 1 and 2 should be replaced with, is the first one. Line 1 should be replaced with def get name. Line get. Oh, there's two answers, line 1 and line 2. So the first and 4 are the answers. Moving on, you work for a company that distributes media for all ages. You're writing a function that assigns a rating based on the user's age. The function must meet the following requirements. Anyone 18 years old older receives rating A. Anyone 13 or older but younger than 18 receives a rating of T. 12 years old or younger receives C. And if the age is unknown, the rating is set to C. So it's going to be the first one. Moving on, consider the following Python code. If the user provides input A, then what is the result? The answer is going to be 4. Question 31, consider the code. What is the result? It's going to be OLLEH. Question 32, consider the code. What is the result? It's going to be 13, 40, 17, 10 for the first answer. Moving on, question 33. You want to add comments to your code so that other team members can understand it. What should you do? Place a comment after the hashtag sign on any line. I'll leave you a comment. Question 34, we are creating a function to calculate the power of a number by using Python. We have to ensure that the function is documented with comments. Consider the code, line number included for reference. So which of the following statements are true? Line 1 through 4 will be ignored for syntax checking. Because they're filled with comments, they're going to be ignored. Moving on, you're writing a Python script to convert student marks into grades. The grades are defined as follows, and developed application is this. Which of the following changes should be performed to fulfill the requirement? And no changes are required, which means this works. Moving on, question 35. You're writing 36. You're developing a Python application for an online product distribution company. You need the program to iterate through a list of products and escape when a target product ID is found. So which of the following code can fulfill our requirement? It's going to be the first answer. Thirty-seven, you're writing a Python program that displays all prime numbers from 2 to 200. Which of the following is the proper code to fulfill our requirement? And it's going to be the first answer as well. We created a following program to locate a conference room and display room name. Team reported that the program sometimes produces incorrect results. You need to troubleshoot the program. Why does line 3 fail to find the room? It's going to be invalid syntax. Question 39, XYZ book company needs a way to determine the cost that a student will pay for renting a book. Cost is dependent on the time of the book's return. However, there are also special rates on Saturday and Sundays. The fee structure is shown in the following list. The cost is $3 per night. If book is returned after 9 p.m., the student will be charged an extra day. And the book is rented on Sunday. Sunday will get a 50% off for as long as they keep the book. Keep the book. If the book is rented on a Saturday, the student will get 30% off for as long as they keep the book. So we need to write the code to meet these requirements. If the book is rented on Sunday, the number of books rented is 5 and book returned after 9 p.m., then what is the result? It's going to be the third one. Cost of the book rental is $9. Question 40. We are developing one school automation application. If a student marks between 80 and 100, then we have to offer a grade. Which code block do we have to use? It's going to be the third one. Between 80 and 100. Okay. And yeah, it seems like another problems. I'll go over this. The XYZ organic company needs to use a simple program that their call center will use to enter survey data for a new coffee variety. The program must accept input and return the average rating based on a 5-star scale. The output must be rounded to 2 decimal places. And in which the following print statement should be placed at line 1 to meet the requirement. It's going to be the first one. I think we might have went over this. All right, those are all the questions. Question 31. So for 31, this code it prints the end message. So it's going to be hello, but flipped. And we're starting with range 0 with the link, the message, right? And the end message starts with starts backwards, and then that's how we get this answer. All right. If there are no other questions, I'm gonna move to the next speaker.
Okay, so that next speaker is me. So today we're going to be going over pandas, which we were originally going to start last week, but yeah, we didn't have time to do it last week, so we're going to be doing it this week. So I'll just begin sharing my screen. Okay, so the first thing is basically, of course, like what is pandas? By the way, just let me know if you can't see the screen or not. But the idea. Oh wait, hold on. Let me have my camera on. But the idea is basically, so later in, like, I guess this course, you guys are going to be learning like machine learning and things like that. And the big thing about machine learning is that you need data in order to like have the machine learn stuff, right? So usually that data is in the form of, like, for example, Excel spreadsheets or like tables, things like that, right? So you want a way to like kind of like read the tables without like hard coding it, because of course you can just like input the tables in yourself, like manually using like arrays and all that, but that gets tedious, and if you have like thousands and thousands of data points, that's going to take a really long time to do by hand. So fortunately there is a solution to this. So that solution is called pandas, and it's basically a Python library for working with these kinds of data sets, mainly like Excel spreadsheets. Yeah, so basically the idea is that it makes working with a lot of data sets much easier, and also you can also make them, you can like modify the data. So for example, if I only want to get like the first two columns of the data and use that in my code, then I could do that with pandas, instead of just like only. There's a lot of flexibility in pandas as to like which parts I can use and which parts I can choose to like throw out. So yeah, here are like some examples of like how pandas relates to data. So for example, correlations, like the average value of all the values in like a column or a row, the maximum value, whether that's within the whole data set or just within one column. And then there's also the minimum value, which basically works the same thing. And yeah, basically that's it for this section. So the thing about pandas is that it is not pre-installed into your system when you install Python, because this is more like this is like a library that's been made by people who use Python as opposed to like the actual Python developers. So you do need to install this separately. So in order to show how to install that separately, I'll be showing that. So Here I'm going to open the command prompt. Hopefully you guys can see that. Oh wait, hold on. Something's not right with the share screen. Hold on, I'll try this again. Okay. But yeah, let's say I go into Visual Studio Code. Um, Hopefully you guys can see this screen. And essentially, what I've done is that I just have like a new program running. It could be an old program. It can also be a new program. It doesn't really matter. And what I'm going to do is I'm going to go to, let me zoom in. Okay, maybe not that much, but yeah, so you guys can hopefully see this terminal button here, right? So what I'm going to do is I'm going to click terminal, and then I'm going to hit new terminal. And this kind of pops up like the command prompt kind of thing, right? And essentially what I want to do is I want to first do Python, or sorry, not Python, just py, and then is like kind of like squiggly line n, and then let's see. Hold on, I had this pulled up. Sorry, give me 1 second. Oh, okay, all right, got it. So sorry about that. So yeah, you're gonna want to install copy paste this command. Okay. Yeah, you're gonna want to copy paste this command. Replace package name with pandas because that is the uh, package that we're trying to install. And essentially, what we're going to do is we're going to just cut and paste that here. Since yeah, so just like delete that and then re-enter this part. So after that, you just hit the enter key. And in my case, I've already installed pandas, so I get like this kind of stuff. This is probably your first time installing it. It should like probably prompt you for like a yes or no or something, like whether you want to install it or not. Just click or just type in Y and hit enter, and then yeah, basically once it finishes, Python, or sorry, not Python, pandas should be installed on your computer. So yeah, just let me know if you have any problems with that. Um, so hopefully, you guys have installed pandas right now. If not, just let me know and I can give you guys some more time. But for now, assuming that you've installed pandas, um, the first thing we need to do if we want to use pandas is we have to import it, right? So we will just use the import pandas. Now the thing is that even though here it says import pandas, usually, yeah, usually most people we do something called import pandas, and then we do oh wait, hold on. Oh, this should be dot py. So usually when we import pandas, we usually do import pandas as PD. Okay, that is not supposed to happen, but the idea is essentially we can replace pandas with PD. So, for example, when we're using like the pandas commands, instead of writing out pandas as a whole, we can just use PD. So yeah, that's pretty much it for this. Oh, okay, and they cover it here. But yeah, the idea is that, for example, instead of writing pandas.dataframe my dataset, you can just write pd.dataframe my dataset. So it makes your code a lot more simpler because you only have to use 2 characters instead of 6. If you want to check the version, you can use this command, the print pd.version, just to make sure that you're up to date. So to test that this works, I'm gonna run that. Okay, interesting. Is it this? Oh. Okay, let's try that again. Hold on. Okay, not. Not that. Yeah, usually this doesn't happen because I already have pandas installed, but maybe okay. Yeah, maybe reinstalling it might work. So yeah, we're going to just run a new terminal, and then hopefully it works this time. It's not available. That is strange. Okay. Sorry guys. Just give me 1 second. Okay, sorry about that. Never mind, I just fixed it. But yeah, when I run this, yeah, now it should say 1.4.3. So, yeah, that was weird, but it works now. So yeah, basically that's it for this section. Again, if for some reason Pandas does not work on your computer, just let me know. So the first thing about Pandas are the series, and basically a series is just kind of like a column in the table. So it's like a 1D array. So the idea is that basically it's just like a list of numbers pretty much. And you can like convert a list to a Pandas series. Now, at first glance, they might look identical because like they both got the square brackets and stuff. But a Pandas series is more like it's more attuned to like the Pandas library. So like the commands in the Pandas library. So that's why we can't use just like a regular list for a Panda. So if we want to convert a list to a series, we just use the pd.series, and then in parentheses we put the name of the list. And there are also things called labels. Labels are just basically the index numbers. So for example, my var 0, that would just be the first value of the series. So a lot of this is very similar to lists. Now, for the unique thing about Pandas is that you can create your own labels. So here, this is just like your default labels with 0, 1, 2, 3, etc. But like, for example, here, we can essentially replace the labels with X, Y, and Z. So as you can see here, X corresponds to 1, Y corresponds to 7, and Z corresponds to 2. So if I were to print like my var X, oh wait, hold on, there are several things wrong here. Yeah, so if I were to print out my var X, as you can see here, at the very top, it prints out 1. So you can, instead of like having 0, 1, 2, 3, 4 as your indexes, you can have like these unique custom indexes. And essentially you do this by using the pd.series, which is the exact same command that was shown up here when we were converting it to a list, or sorry, converting a list to a series. And then we add this new argument, index equals XYZ. Here they chose XYZ because that's what they want their labels to be. But you can, of course, replace these indexes with different things. And yeah, when you create labels, you can basically refer it to that label instead of the index. Other things that can be stored as a series. So for example, dictionaries can be kind of like stored as a series. So here we have like a key value pairs. So like for example, day 1, 420 calories, day 2, 380, day 3, 390. And you can essentially convert this dictionary to a series, and it'll pretty much work the same way. And by the way, if you want to only specify some labels that you want to change, you can do that by just specifying which labels. So for example, here we want for this one, this is when we want to only pick some of the values from the list. So for example, here we can see that in this dictionary, we have 3 values, right? Day 1, day 2, 3 keys, day 1, day 2, and day 3, right? But the thing is that, what if we only want to create a series with just the first 2, right? In that case, we would just use day 1 and day 2. So by doing index equals day 1, day 2, we're only getting the 420 and 380. So yeah, when we print it out, day 1 420, day 2 380. Also, you might be noticing like what's this D type int64 that keeps popping up. That's basically like the type of the values inside of the series. So here you can see that all of these values are ints, and to be more exact, they are 64-bit integers. So that's why it's int64. Now, if series are like lists, then data frames are like 2D lists. So when you want to like import a table, you usually use data frames instead of series because data frames allow multi-dimensional functionality. So yeah, as shown here, we have in this data frame we have 2 columns essentially. The first one is like calories and the second one is the duration, and then under those 2 columns there's like numbers, right? So like 420, 380, 390, and then for duration it's like 50, 40, 45. So if you want to print it out, then you can see it kind of like sorts itself to like a table here, right? So this 0, 1, 2, that's just like the index numbers, like the row. You can kind of think of it as the row numbers because that's basically what they are. So 0, 1, 2 are just like your row numbers, and then calories and duration are your 2 columns, and yeah, as you can see, they're like sorted into like a table. So what is a data frame? So yeah, as we've explained before, it's essentially like a table, like a 2D array. You can kind of think of it as either one of those. And now we get into like kind of like the functionality. So the most basic functionality is the location or lock, because that's how you get specific rows and specific columns. So if you want to get a row, all you need to do is you do df. The reason why it's df is just because I believe that's the name of their data frame. Yeah, df is just the name of their variable that they chose to store the data frame. So it's not like it's always df, but it usually is because that's what most people name their data frames. So you do that and then dot loc, and then inside these square brackets you put in the row index. So for example, if you wanted the first row, that would be row 0, and if we look up here, that will be calories 420 and duration 50, right? So when we print it out, yeah, as we can see, we get those values. And then the name is just referring to the row number. So in this case, since it's row 0, it's just 0. And again, a D type or data type, that's referring to the data type of the values. Both of these are ints, so it's int64. And as you might notice, this is actually another column in of itself, because let me show this with like kind of like a picture. So like here we have our table, calories and duration, and essentially we're getting this row, right? Now, if we were to like flip that row from horizontal to vertical, then we would have a column, right? So like something like this, 0, 420, 50. And essentially, as we've covered before, a column can kind of be represented as a series, right? So essentially, the idea is that when you get a certain row or column in a data frame, it is you're basically returning a series. Now, of course, you can call multiple indexes. So, for example, if you want to get the first 2 rows, so 0 and 1, you might notice that you have double brackets here, and we'll go into that a little later. But for now, just know that you have double brackets, including the 0 and 1. So yeah, now we get a table kind of like this, and as you can see, it's kind of like another data frame because we have multiple rows and we have multiple columns. So you can see that it's a data frame, and that's part of the reason why we used two brackets, because two brackets shows that it's a data frame and not just a series. So like it's two-dimensional. And as said before, you can name your own indexes. So if you look back before, you can see that our labels were like 0, 1, 2, 3, because that's just the default that Pandas gives to the data frames in series. But as before, you can change those labels to something more specific. So for example, since this is like a calorie counter or something, we can change it from 0, 1, 2 to like something more specific, like day 1, day 2, day 3. And the way of doing it is pretty much the exact same. We just do index equals, and then the square brackets just contain like what we want the labels to be. And finally, we have for location, we also have like naming specific rows. So here we used 0 and 1. Well, since we've named the labels now, instead of calling 0 and 1, we would just call day 1 or day 2 or something like that. So yeah, as you can see here, that kind of gives us the same result. And finally, the most important part, loading files into a data frame. So when you're eventually working with like data for machine learning, you're going to be importing like a lot of spreadsheets and like spreadsheets, comma separated value files, etc. into your computer, because you want that data accessible to your machine so that way they can learn it, right? So the idea is that we want to import this file into the program, so that way the program we can like easily manipulate the data and like feed it into our machine. So the way to do that is that we can use read, pd.read, and then you might notice that there's an underscore CSV. So that is for a CSV file. If it was for an Excel spreadsheet file, I believe the extension would be like XLSX. And essentially the idea is that this part matches the file type of the file you're trying to import. So here, since it's a CSV, we read CSV. So yeah, I guess there are the next one is like the reading the CSV files, because that's like the most common way to like import data into your program. So a very simple way is, again, using pandas, which is kind of the point of the library. And we can also just print the data frame just to make sure that everything's in it. So here they have like a sample CSV file for us to look at. And essentially, when we print out the data file, we can see like kind of like the table, right? So again, since the labels are unnamed, it's just the default like numbers. And then here we can have we see all of the columns: duration, pulse, max pulse, calories, and then all of the numbers listed under it. It doesn't print out every single number because, as you can see, this data file is quite large. 169 rows and 4 columns. So it's not going to print out every single number, but it'll like print out like the first like 5 or so numbers, or sorry, first 5 or so rows at the top, and then like the first 5 or so rows at the bottom, just to show like a general idea of what's stored in the table, or sorry, in the data frame. But the entire table will be stored in a data frame. It's just that they're not showing it all at once, because otherwise the output would be way too long. So you can like check the number of maximum rows. So in this case, it would just be 60. And the way we do that is pd.options.display.maxRows. So yeah, that is essentially like, that means that's like the maximum number of rows that the program can display on the output. So if it has more than 60 rows, then yeah, as we can see over here, it only shows the first 5 and the last 5, because otherwise it's way too much to show on the screen. And then if you want to change it, you can essentially set this value equal to some other number. So for here, they chose it as 9,999. So that way you can see like every single number if you scroll down enough. So yeah, we just covered CSV files, which is one way to store data. However, there's also another really common way of storing data, which is the JSON files. So JSON is essentially kind of like plain text, so like TXT files, but essentially it's like stored as an object as opposed to like a regular file. So again, reading in a JSON file is kind of similar to reading in a CSV file. So for a CSV file, this would be pd.read CSV. But since we're now reading in a JSON file, it would now be pd.readJSON because we're reading in a JSON file. And yeah, as you can see, it kind of works the same way. When we print out the data frame, we get the entire table because the maximum number of rows has been changed. So you can also like copy paste the JSON file into your code directly as like a dictionary, which is shown here. It is a bit tedious, but if you want to do that, you can. So this is just showing it. So as you can see here, it's kind of like key value pairs. So again, these are the values and these are the keys, which are like the row numbers represented here. So yeah, that's it for this part. And this is one of the more important parts of pandas, which is of course actually analyzing the data frames and like getting the specific values that we want. So the first command that we can use is the head method, which is shown here. And the idea is that you can like kind of like check the first couple or so rows of the data frame. So here we have 10, so it'll just give us the first 10 rows. And then we can like check that with the file to like make sure that everything's correct and stuff. And by the way, this is just the file we're using. As you can see, it's quite long, so that's why we're only getting 10 rows as opposed to the whole thing. And if you don't specify a value, then it just prints out the first 5 rows by default. But here, since we specified 10, that's why we have 10 rows printed. The same thing applies to tail. So tail is essentially like the last 5 rows by default. So yeah, again, we can also change this. So if I wanted to see the last 10 rows, and once this runs, I will be able to see 10 rows of data, but they're all the last 10 rows. So yeah, tail is for df.tail is for the end of the data frame, and df.head is for the top of the data frame. So yeah, that's it for this part. And we can also use df.info. Essentially, that just gives like random information about the data set that we have, or the data frame to be more specific. So for example, here it gives like the data type of the data frame, how much memory it uses, what kind of data types are stored in it. Kind of like this is more of like a breakdown of like again, what data types are in each row and column, how many columns there are. So this is just like for checking to make sure that everything is stored properly. And it also explains to us that like there are this many rows and this many columns, and like what kind of data types are in each row and column. It also tells us how many null values are in each column. So if we go back to the data set over here, we might be able to see some null value. Yeah, so like for example here, as you can see, it's just completely blank. There's no like fourth column for this one. So that's also kind of represented in the the df.info command. So up next is cleaning data. So if we go back to the data set, you might have noticed like these random holes in the middle, right? And these kind of represent like null values. And the thing is that you kind of don't want them to be represented by null values, because the thing is that it makes programming it much more difficult. So we want to do something called like cleaning the data. And the idea is just that we make the data easier for our program to like understand and like process. So for example, empty cells, data in the wrong format. So for example, if like this data value was like in string format for some reason, we will want to clean that, especially if we're doing some kind of like math with it. Wrong data. So for example, let's say this number was supposed to like be like 500 instead of 700. And then duplicate data. So if we have like a duplicate row or column for some reason. This is just showing what data set they're going to be using in their examples. And as you can see, there are some empty cells. So for example, this, like these NaN, that means that it's null, or like there's basically nothing in those cells. Wrong format. So for example, if we look at row 26, this one is not enclosed in quotations as it should be. And we have some wrong data in row 7. So presumably one of these values is supposed to be wrong. Oh, duration. So yeah, as you can see here, it should not be 450, it should be 45. And finally, we have duplicate rows, so like 11 and 12. So these are kind of like the examples of errors in your data that you will probably want to clean up before you start analyzing it. And yeah, we're going to figure out how to do that. So empty cells. So the issue is that when we're going through like a data frame or a series, and for example, let's say we're like trying to find the average, right? So we add up all of the values in like each column, right? The issue with having a null value is that you can't add a null value to an integer or a float, right? It has to be the same data type. And since null is not a data type, like that creates an error. So there are several ways to fix this. The first one, which isn't mentioned here yet, is of course just like filling in the null cells with like actual data. So for example, if that null value was supposed to be like 0, you would actually like fill in the null value with 0.0 or whatever value it should be. So that way you don't have any null values in your data. Another way is just to like remove rows that have empty cells, because you're probably not going to use it. Especially if your data set is very big. So like for example, if you have like 100,000 data points, right? And let's say like two or three of those rows have like a null value. If you remove those data points, that's not going to affect the accuracy of your machine or like how well it trains, because it's like such a minuscule number compared to like how many total training points you have. So like sometimes it's okay to just like remove null data points. So for example here, we are going through the data frame which we have read in comma separated values file. And here we have our new data frame, df.dropNA. DropNA is basically like dropping anything that's null. So anything that has a null value, we will remove that row. And then when we print out the new row, essentially, yeah, some rows has been removed. You can notice like the jump between 17 to 19. There's like no 18 in the middle, right? That's because that had a null value and it got removed. So yeah, now we're left with a data set that is mostly clean for the most part. Now, the thing about this is that you're technically creating a new data frame. So new df is a separate data frame from the old df. So like you still have the old access to the old data frame set before you remove all the null values in this case. But sometimes if you just want to like remove the like the error rows directly from the original data frame, we can use df.dropNA and then in place equals true. So that way, when we print out df, like it's like permanently removed from the original data frame. Now the reason why we need in place equals true is that if we just remove this, then nothing should happen, because the thing is that you have to set df.dropNA equal to something. So if we look here, the null value row is still there. That's because we need to technically set this equal to like df2 or like some new variable. But if we have the in place equals true, yeah, then it will do that automatically. So now when we run it again, they should be gone. Finally, another way, which I kind of talked about before, but another way to deal with the empty cells is to fill them in with like some value that will actually work. So for example, here, instead of just like removing it completely, we can fill it in using fill.na. So here it was drop.na, which basically means like to remove it, you're like dropping it from the data set. Fill.na is like filling it in, so it's like filling in the cracks in the data set. And here we specify that we want to replace it with 130. And of course, in place equals true means we want to modify the original data set. So when we run it, 18 used to have like the null value over here, but as you can see, it's now been replaced by 130. Same over here. And yeah, same over here as well. So now, when we like analyze data by like, when we analyze the data by running like our code through it, it should work more smoothly now, because now every single data point should have the same data type. So it makes, for example, like computations much easier now, because we don't have to worry about like type changes or things like that. Of course, you can also replace it for specified columns. So for example, here we can see that they used a square bracket for calories, and then they replaced it for 130. So as you can see here, since date is not part of the calories the calories column, this null value is not replaced, but the other ones, like for example this one, are replaced because it's under the calories row. You can also replace it with, for example, like the average, median, or mode. This is good if you don't know what the value should be for the data set. So you can just like kind of like fill in the cracks using the data that you already have. So in this case, we basically set a new variable x equal to the average of every value in calories, in the calories column, and then we fill in basically any null value with the average value. So here it's dot mean. Mean just means average. Median is like the most middle value in the column, and then mode is just like the most frequent value in the column. So depending on what you want, you would either use the mean, median, or mode function. Here they're using median, and here they're using mode. You might notice that there is like, was it like an index number here? That's because you want to specify. Sometimes there might be multiple values that repeat multiple, like the same number of times. So for example, there might be an equal number of fives, of twos, fives, and like tens, right? And essentially, the 0 is specifying that you want the smallest, like the smallest, most frequent data point, if that makes sense. So that was clearing all of the null cells, but let's talk about like cells that aren't necessarily null but still in the drawing format. So for example, all the way down here, we have an issue because this is represented as an integer when it should be like a string, right? Because the date should be like a string value. And this could mess up your code because again, it needs to be consistent with the data types in order for like certain like functions or calculations to work smoothly. So yeah, how do we fix these? Now we could do the thing that we did before where we just like remove the rows, but we can actually just convert it directly. So for example here, we can actually, Python has, or sorry, not Python, but Pandas has inbuilt function to datetime, where it will essentially convert like wrong dates into like the correctly formatted dates. So like this would turn into something like 2020/12/26 as it should be. And in order to do that, of course, we have to read in the data file. This is just specifying which column. So this is the date column. And then essentially it'll convert the entire data it'll convert that entire column into like the date time format. So now when we look at it, you might notice that it's now, instead of slashes, it's now dashes. And then if we look at 26, we can see that it has changed as well to like fit the rest of the format. So yeah, that's nice. And yeah, that's kind of the result. Oh, but the issue is that for 22, 22 was a null value, right? So let me go back to original data set. So yeah, 22 was a null value because this is before we cleaned it up with like the empty cells and stuff. So since a null value is not a date and time, this NaN gets turned into an NaT, which stands for not a time. So again, you can either remove the entire row, or we can do what we did in the previous section and basically fix all of the empty cells before we format everything. And like I said before, you can also just remove the rows completely. So here we again just like drop any null value within this certain column, which is the date column. And of course, in place equals true. That just means that we want to modify the original data frame directly. So you might be wondering, why is it drop NA? Because the thing is that it works regardless of whether this is a null value or not. So here in this case, here in this case, NaN was a null value, so that's why it got turned into NAT. But lots of other things can also be turned into NAT as well. So for example, if I put like pandas and I replace that over here with like the word pandas, obviously pandas is not a date or a time, so that would also return NAT. So that way, when we use this command, it removes all of the NAT values. So in effect, it removes all of the values that are not a date and time format. So yeah, the next issue that you could probably come across is having bad data. So for example, here, the person probably meant to type in 45 instead of 450, because 450 minutes, that is a long time for exercising. But yeah, it's not, as you can see, it's like not consistent with like the other data values. So this is most likely a mistake. So how do we fix it? So one way to fix it is we can just fix it directly. So when we do df.lock, remember df.lock is like the location function, right? So it like locates the specific value and data that we want in the data frame. So this is specifying row number, so 7, and then you can see that it's a duration, right? So that's column number, or not column number, but like column name. So we do it by row and then column. So that leads us to this data point, and then we can like set it directly equal to 45. So now that way, when we run it, we've essentially fixed the typo. So yeah, since this data set is only 30 or so values, it's fine to like fix it one by one. But for larger data sets, it's kind of impractical to do that because, well, you just have more rows and more columns, and it's difficult to like check every single one. So in order to do that, you can like kind of use like a for loop and if statements, and basically kind of do it automatically. So for example, here, if the duration is longer than 120 or 2 hours, then we just set it to 2 hours. So for example, this 450, that will instead be replaced with a 120 because 450 is greater than 120. So yeah, it'll be replaced with 120 like that. Of course, there are pros and cons to this because, as you can see, 120 is probably not the duration that the person exercised for. It was probably 45 and just a typo. But the good thing about this is that it's automatic. So if this was, say, like over 1,000 days, it will be easier to like correct mistakes like this instead. So of course you can also just remove the row itself. And again, the thing is that if your data is sufficiently large enough where it's kind of like impractical to check it one by one, then it should also be fine if you remove a couple of rows or data points, because your data set is so large that it'll essentially make up for it. So here, if it's higher than 120, then we will drop that row number. And of course, we'll use the in place equals true, which just tells the program that we are modifying the original data frame. So as you can see here, yeah, row 7 is not visible at all because we just simply dropped it. Last but not least, there's removing duplicates. So for example, in row 11 and row 12, we can see that they have the exact same values, and it's unlikely that the person had the exact same stats for 2 days in a row. So it's most likely an error, and we'll probably have to remove one of these or fix one of them. So when we use print df.duplicated, essentially we'll get kind of like a, I guess it's a series of values, and we'll see whether each row got duplicated or not. So if we scroll down, most of them are false because most of them are unique, but we can see that for row 12 it says true, and row 12 was the duplicate of row 11. So that's how we know that row 12 is a duplicate, and then we can either figure out whether to drop that row or to modify it depending on how the data works. That's kind of like on a case-to-case basis. And again, if you want to remove the duplicates, you can also just do df.drop and then underscore duplicate. So you're basically dropping all of the duplicates. And in place equals true, again, that's making sure that instead of creating a new data frame, it like modifies the original one. So yeah, that should be it for that section. So up next we have correlations. So this is represented by the CORR method, and essentially it's kind of like basic analytics on your data set. So again, they're going to be using like this CSV file, and when we use df.core by itself, we can kind of see like these various stats, and essentially you might notice that all of these numbers are within 1 to -1. So what does that even mean? So essentially 1 and -1, those kind of represent like positive and negative correlation. So for example, if I just go to Desmos really quickly, let's say I had like 2 data points. This is not very good data, but for the sake of this argument, okay, actually we'll use 3 data points. So let's say we have something not like that, but like let's say these were our data points 0, 0, 1, 1, 2, 2. You can see that this essentially has perfect correlation, right? Because I can like literally draw a perfect line that fits all 3 data points exactly. So this would be considered +1 correlation, because it's like perfectly aligned. Like I can draw a best of fit line that would go through all 3 points perfectly. So that's like +1. -1 would be something like let's see, like 1 or 0, 2, 1, 1, and then 2, 0. So this is like the opposite case, right? It's negative correlation because as x increases, y decreases. So it's like opposite of each other. And again, just to make sure, the red point is first, and then we're going to the black point. So this is perfect negative correlation because, again, I can draw a line of best fit that goes through all 3 data points exactly. And it's negative because it's a negative relationship. When one increases, the other one decreases. So this would be perfectly -1 correlation. Now, of course, you might have some like, of course, not all of your data is going to be perfect. So, for example, for 1.5, this would still be negative correlation, but it wouldn't be -1 because it's not perfectly aligned. It's like you could like draw a line; it'll be pretty close, but it's not like perfectly aligned. And then you also have stuff like no correlation. So I'll just pull up a graph for that one. But like if you have a no correlation scatter plot like this, that would kind of be like 0, or at least very close to 0, because you can't really like draw a positive or negative line through this data set, because like it's not even like when x increases, y increases, or when x increases, y decreases. It's a little random. So That's why we can't. This doesn't have as strong correlation. So let me just close out all these tabs. But that's kind of like what the correlation means. Essentially, like how strong is like the correlation between the data sets. So essentially, yeah. So for example, 0.9 or like 1, that's like perfect or at least close to perfect correlation. So if you input a new value that's like higher than the previous one, the result is likely to go up. -1 and -0.9, in terms of correlation strengths, they're the exact same, but it's just that it will go down instead of up. And then like 0.2 or like something close to 0, that's probably not a good correlation. Like there's not as high, it's not as strong. So for example, pulse and duration, the correlation between those two variables is not as strong as say like duration and calories burned. Like if you're exercising for more, of course you're going to burn more calories, but if your pulse is high, that doesn't necessarily mean that you're burning more calories. That could be a lot of things. So that's just kind of like what correlation or df.core shows. It's like what are the most common variables that will be kind of like linked together. And of course, the diagonals are all 1. This is because, of course, duration, the correlation between those two will be like the strongest, right? Because if you increase duration, then of course duration increases. So that's why all of these values are 1. Good correlation is kind of subjective, but for their example, they're considering 0.6 or higher to be good correlation. Again, that's kind of subjective. There's no like right or wrong answer to that. It kind of depends on the problem. And yeah, that's basically it for this part. And of course, we also have plotting because, of course, every single like data analysis will not be complete without some graphs, because graphs are kind of like the easiest way to show data correlations and stuff like that. So in order to plot graphs, you use the plot method, which is kind of self-explanatory. And we have to import something called pipeplot. This is from the matplotlib library. I'm not sure if we covered this already, but essentially what matplotlib is that it's a way in Python for you to like kind of like graph your own data. It's like that way you can like make graphs like these. It's very handy in like data science and stuff like that. And again, you might notice that there's like this as PLT. That's because we don't want to write matplotlib.pyplot every single time we're calling a method from that library. So we just do as PLT to like make it shorter. So that way, instead of writing like matplotlib.pyplot.show, we can just write plt.show. So it's a lot more simple. And essentially, when we run this code, it kind of like graphs everything. So if we look at the data, we can kind of see like what each like line represents on this diagram over here. And it's also like kind of like scale nice as well. So this is just like your default plot. So like essentially pandas will just find the like, I guess, quote unquote, the best plot to represent your data. But of course, you can like change that with settings and whatnot. Now, you can also specify what kind of plot you want. So for example, this was a line plot where everything is like kind of connected and smooth and all that. But you can also have a scatter plot. And the scatter plot is basically like, it's like a bunch of dots. They're not connected, but like you can kind of like make out the general shape of the graph. So with the scatter plot, you generally speaking only have two things you're comparing, and one of them is going to be on the x-axis and one of them is going to be on the y-axis. So it's not like this where it's like where there are no labels on the x and y axes. For scatter plots, you generally speaking are comparing like two values. So yeah, as you can see here, it's more sporadic, and on the x-axis we have the duration, and on the y-axis we have like the calories burned. And the way they programmed it is they just read in the data file, and then they use df.plot to like plot the graph. They specified the kind of the kind of plot they wanted, which is the scatter plot, and then the duration was the x-axis and the calories is the y-axis. So yeah, you get something like this, and here it's a lot easier to see the correlation between duration and calories as opposed to like a graph like this, right? Here in this graph, there's kind of a lot going on, and you kind of can't tell whether duration and calories have like a strong correlation or not. But like here, you can definitely see it because like as duration goes like higher, calories burned also goes a lot higher as well. So yeah, you can tell that this has probably strong correlation. Now you can also show, so this was an example of very good correlation because you can kind of like visualize a line going through all the data points, or at least like close enough to the data set. Now if they compare something like duration and max pulse, you get something like this. It's a lot more difficult to draw a line that connects all the data points accurately. So this would be kind of like considered no correlation because, yeah, you can't tell whether duration, like more duration will be higher pulse or more duration will be less pulse based on this graph. It's kind of hard to tell. And if we look at this graph, duration is blue, max pulse is green. Yeah, they kind of like, you can't really like tell if they have correlation at all because it's not even like they're going up and down at the same time. Like if we were to compare duration and calories, you can see like the peaks are happening at like roughly the same instances, but like for duration and max pulse, that's just not happening. So that's why this correlation is not as strong. Another kind of plot you can have is like a histogram. So these are kind of like the bar graphs that you might have seen before, but essentially they look something like this. And the idea with a histogram is that it represents the frequency of a certain kind of point. So as such, you'll only have one column because the y-axis is always your frequency. So here they specified a histogram plot, and they want their their data to be based on duration. So the idea of this is basically, roughly 30 workouts happen between 0 and 50, between 0 and 50 minutes, and then like over 100 were between 50 and I would guess that's 75. And then like 75 to 100, that's like roughly 10 workouts happen between 75 minutes and 100 minutes, and then so on and so forth. Like you can kind of see the idea. But basically it kind of tells you like what the peaks of the graph are. So like here you can see that most workouts are being done like roughly in the 50, maybe 60 or 70 minute range. And then these are mostly like your outliers. You can of course like change how big or how wide the rectangles are through like bins and stuff like that, but that's more like a matplotlib thing as opposed to a pandas thing. So we're going to kind of like skip that. And okay, we should just have the quizzes now. So yeah, this is, by the way, this is just like a reference as to like all of the functions that's available in pandas. You definitely do not need to know all of these, but just like some of the key ones that we've already covered. So like, for example, the core function or like the lock function, those are very important. But yeah, I guess now we just go through some exercises, I guess. Or sorry, give me 1 second. Okay. Okay, I think something happened, but I think we're fine. Um, so yeah, for this exercise, essentially, we want to insert the correct pandas method to create a series. Um, so I guess the way this works is, how do we do this? Give me 1 second. So yeah, essentially what we want to do is we want to create a series, and of course we can find the command that basically matches the blank in here. So yeah, I guess you guys can like type in chat or something, so, and kind of like give your best guesses. This is by the way in like chronological order, so like this will be testing stuff that we covered at like the beginning, and then it'll like progress more towards the end later. So for this one, basically when we want to create a series, we just do pd.series. Hopefully that's correct. Yeah. So essentially, when we create a series, we want to use the series method. So for the next one, they want the correct syntax to return the first value of a panda series called my series. I guess they should have specified the default value, because technically speaking, the first value can be anything if you change the label, but they want the first value by default. And yeah, that would be basically the brackets and 0. So kind of like a list, right, or a string. Like the first index is we always start from 0, because yeah, that's just how Python works, I guess. Yeah. Now here, we want to like kind of change the labels to X, Y, and Z instead of like the defaults of like 0, 1, 2, and we want to figure out how to do that. So for this one, first we set it equal to, of course, X, Y, and Z, and then I believe this should be index. So we are setting the new indexes, and then they're equal to X, Y, and Z in that order. So yeah, yeah. Hopefully you guys got all those 3 on your own, and I guess we'll continue to move on. And of course, just like stop me if you have any questions or anything. So in order to create a data frame, just like how for series it was like pd.series, for the data frame it's essentially the same thing. Pd.data frame, like that. Yeah. Oh, why is it not? Oh, I'm clicking the wrong button. Yeah. Okay. So yeah, when we create a data frame, it's pd.data frame. Now we want to insert the correct syntax to return the first row of data frame. Again, technically speaking, this is like the first default row, because again, you can like change the labels of a data frame. But what they want is they want df.lock because lock is like locate, right? So you want to locate the 0th value. Now we want to read a CSV file. We're assuming that data is a string that represents like some kind of CSV file notation. So assuming that data is a CSV file, we will want to read it. And then on the underscore, that's just like a space and then CSV. So it should be read underscore CSV data. And of course, the CSV gets changed based on the data type of the file you're trying to read. So maybe this might be the next question. Okay, maybe not. But like, for example, if it was like a Excel spreadsheet, it would be like read XLSX because that's the extension for an Excel spreadsheet. Now we want to insert the correct syntax to return the entire data frame. So this is like essentially what are they asking here? Like they want the entire data frame, so I'm assuming they want us to print. What did they mean by this? Hold on. What they have here? Oh, they want to string. Okay, so I see. So essentially what this program is asking, or this question is asking, is how do you want to like print out the data frame? So one way of doing it is you can do df.toString. Oh, did I forget something? Oh, to underscore string, sorry. Because you can't use a regular toString method because the thing is that this is under pandas, not regular Python. But this essentially converts the data frame to a string that can be printed and basically treated like a string. The thing is that you can also print out a data frame by itself. So if you just want to print out a data frame, like you can just use print df as opposed to just writing print df.toString. So either version works, but in this case, they want us to like actually convert it to a string. So that's why we would use df.to_string. So yeah, okay, that's correct. This one I was kind of touching on before for df. Read CSV. So like when we read a CSV file, it's read underscore CSV. But since this is a JSON file, we'll do read underscore JSON because it's a JSON file. And yeah, that should be correct. We want to now load in a Python dictionary called data into a data frame. So in order to do that, we can just do, so going back to some of the examples, right? For example, we had a data, or sorry, no, that was not it. No, that was not it either. Where was it? Huh, was it? Maybe it was here. No. No, it's not here either. There was a part where they showed a dictionary. Just trying to find that. Okay, maybe it wasn't. Okay, it was this one. Yeah. So here you can essentially convert a series, or sorry, a dictionary into a series, and that's kind of like what they're testing on here. So as you can see, it doesn't really matter. Here they want to, here they want to convert it to a data frame. So in this case, it will be data frame. But and you can also convert it to a series depending on what you want. So if you want just like one column, it will be a series. But since they want a data frame, it will be a data frame. So yeah. Now up next is returning the first 10 rows of a data frame. So for this one, remember it's like heads and tails. So head of course represents like like the beginning or like the top part of the data frame, and then tail represents like the bottom half of the data frame. So if I want the first 10 rows, I'll do df.head. But since head, okay, since head by default, okay, so okay, so anyway, so the issue is that head by default is 5, so this will be 10. So that's specifying that it's 10 rows instead of 5. Yeah. So basically it's just asking how many rows are returned by default. Like I said before, it's 5 rows. Okay, yeah. So this is just asking what if you want like the last 5 rows or so of the data frame. This will be the tail method, because you can kind of think of it as like heads and tails, right? So if head represents the top, then tail must represent the bottom. The next thing is, of course, the cleaning. This was like the stuff where we removed all of the null values or the duplicate values, or like the things that were in the wrong data type or something like that. So for this one, we want to drop or remove rows with empty cells. So remember, this was like df.drop na. So that drops any row with a cell that has like a null value or like a NaN value. So here we want to replace every cell with the value 130. So if we were to look at the, which one was it? Wrong data. This was like the thing where 450, the duration was inaccurate, and we wanted to replace it with like something else, right? So where was it? Over here. So yeah, over here you can just like directly replace it, or oh, interesting, it's not here, but oh, maybe it was this one then. Okay, I guess it was not this one either. Weird. But like essentially this is like you like fill in the null values. So yeah, I'm not sure where that went, but like we should have covered it somewhere. Oh, okay, it was here. But like, yeah, the idea is that we replace it's like filling in the null values with like a new value. So that would be fill na. For this one, we want to insert the correct argument to make sure that the changes are done for the original data frame instead of a new one. So for this one, you might have noticed that, yeah, well, it says right there, but in place equals true. So essentially, if you do not have in place equals true, what will happen is that it will make a new data frame with like all of the changes that you wanted, instead of like modifying the original data frame. So if you want to modify the original data frame, you have to use the in place equals true command or argument. And finally, removing duplicates. So so for the null values, it was drop na. So this should be drop duplicates. Actually, maybe not. Oh, I'm missing an underscore. That's why. But yeah, this should be drop underscore duplicates. And yeah, that should work now. Now this was like kind of talking about the correlation. So like the positive correlation, no correlation, negative correlation kind of thing. So if you want to find the correlations between all the columns in the data frame, we will just use the CORR method, which stands for correlation. Again, this kind of depends on the problem you're trying to solve, but for the purposes of this example, usually it's true. Usually a correlation of 0.9 is good. Like basically the closer it is to like 1 or -1, the better it is. A correlation of -0.9 is also considered a good correlation. In terms of like strengths, it just means that it's negative correlation. But negative or positive correlation, that doesn't matter in terms of strengths. It just matters like the absolute value of the correlation. So since 0.9 is very close to 1, this is also true. It's also considered good. And again, if there are any problems, just like stop me or something like that. So now finally we're in like the last couple of exercises. We want to first plot or visualize the data in the data frame as a diagram. Essentially they're asking like what the command is for plotting the data. That is df.plot. So here we want to specify that the plot should be of type scatter. So essentially we just do type equals scatter in like quotation marks like that. Okay, maybe it was not type. Okay, it was kind. Yeah, it should be kind equals scatter. So like, what kind of plot do you want? The kind of plot we want is scatter. And for this one, we want it to be a histogram. So again, kind of similar thing, histogram. But this should be it's shown over here. But yeah, kind equals hist. Oh, so actually we don't need the whole histogram keyword. It's just hist because it's just shortened like that. So it'll be kind equals hist. Yeah, so that should be all of the exercises. Those were just kind of like reviews of things that we've covered throughout this class. Again, if you guys have questions, don't be afraid to say any question and answer. And I believe this should be the last part for today's lecture because I don't think there's anyone after me to present. So with that being said, I'm gonna stop sharing my screen here. And yeah, I guess hope you guys have a good rest of your day. See you guys later.